Hello everyone and welcome back to the channel. This video will be the first of a series of tutorials on Anthropic's MCP. Let's get started. So to really understand what MCP is about, we'll try to answer three main questions. First, what problems does MCP try to solve? Second, how exactly does MCP work? And finally, what does MCP really bring to the table? So how did we get to MCP? A good place to start is by understanding how large language models are able to use tools in the first place. Large language models are text generators, so they are actually incapable of taking any kind of action. They can only generate text indicating the action they want to take. To use tools with our model, we must therefore always follow this 5-step process. First, we call the model with our initial prompt. This prompt should contain both our query and our list of tools, with a full description of the purpose and parameters of each tool. Second, if the model decides to use the tool, it outputs a tool call which specifies the name of the tool and the parameter values that we should give to the tool. Third, we, ourselves, execute the chosen tool with the given parameters. Fourth, we send the results of the tool as a tool message or tool call output to the model. And finally, the model acknowledges the result and incorporates it into his following answer. Now, thanks to powerful agentic frameworks like LangGraph or CrewAI, the internal steps 2, 3, and 4, parsing the tool call, executing the tool, and sending back the tool result, are all done under the hood, which makes it seem like LLMs directly use the tools. So the only thing we should actually worry about is the first step. And this is where it gets tricky. The problem here is that the first step is very cumbersome. We have to describe each and every tool in meticulous detail so that the model knows exactly how to use them. The way this is done is by providing a full input schema, as you can see here for OpenAI, or here for Anthropic. What happens under the hood is that this list of tool schemas is injected into a system prompt, which outlines all tool descriptions to the model. Now this specific configuration poses three major problems for AI agent developers. These three problems were neatly summarized in this great blog post by Martin Grutendorst. Everything we've described so far all boils down to this workflow right here. We have a system prompt that is fed to the model. In here we must manually track every single tool, fully describe it, and update it whenever the API changes. Let's take a real-life example to get a feeling of why this is a big problem. Let's say you want to use Tavily as a web search tool. You need to know how the API works by going to the website, reading the documentation, and so on. If you're lucky, you can find clean Python snippets like this, use them to make your tool, and then use the documentation to define your tool schema, with descriptions of parameters and so on. If you're even luckier, you can find integrations like Langchain, for example. They've already done all the dirty work under the hood, and all you have to do is plug your tool to their corresponding framework, LangGraph, and you're good to go. This is pretty much what we did in our last tutorial on AI agents. Now imagine doing this for 5, 10, or 20 tools. Worse, imagine doing it without integrations with your favorite framework. Even worse still, what if at some point the API changes? You would have to manually do all of this, each and every time. Or, you can wait for Langchain to do it for you. Having to track, fully describe, and update multiple tools is unsustainable, especially at scale. And this is the problem that MCP is trying to solve. Of course, we didn't wait for MCP to invent standardized API specifications. We already had standards like OpenAPI, formerly known as Swagger. Amazon Bedrock agents, for example, use OpenAPI schemas to fully describe tools for their models. And we can easily imagine ways to query these schemas at runtime and automatically feed them to the model. What MCP does is simply go a little further. So what exactly is MCP, and how does it work? If we want to sum it up in a few words, it's a complete separation or decoupling of agent developers on one side and tool developers on the other side. The way this is done is with a classic client-server architecture. On the one hand, you have tool developers. They create tools from APIs like Tavily, GitHub, or Google Drive, and then they deploy them as servers. On the other hand, you have agent developers. They create LLM agents, using frameworks like LangGraph or CrewAI. Now, instead of manually giving a list of tools to their model, agent developers will simply plug an MCP client to the model. When the agent starts, the first thing the client does is send a list tools request to the servers. Each server lists all the tools that it has, with a detailed description of the arguments and purpose of each tool. The client then grabs all of this information and injects it into the prompt given to the model, exactly as we saw earlier. The client then acts as an intermediary between the model and the tool server. When the model outputs a tool call, the client parses it and sends the corresponding request to the server. The server runs the tool and sends the response back to the client. And finally, the client parses the response and sends it to the model. Now, how is this any different from what we saw before MCP? The key here is decentralization. Let's go back to our Tavily example. So, remember, as agent developers, we had two choices. The first choice is to wait for our favorite framework, for example Langchain, to do all of the dirty work. They take care of reading the documentation, creating the tool with a complete description, and updating it if there's any change in the API. We then simply import those tools from the framework and plug them directly to our models. This is convenient, but it leaves us at the mercy of these centralized frameworks. The second choice, if we don't want to rely on frameworks, is to do all of this dirty work ourselves. And this is very inconvenient. Now with MCP, there's a third choice. We wait for the owners of the API themselves to do the dirty work and create an MCP server. As you can see here, for example, Tavily themselves made their own MCP server. If we check out the GitHub repo, we can see that under the hood, it's just a wrapper on their API that neatly describes every argument in an LLM-friendly way. This work can also be done by anyone else in the open source community, or, in the worst case, by a dedicated tool developer in our team. And the reason this can work in a decentralized way is the standardization offered by the MCP protocol. If all servers follow the same MCP standards, your MCP client can communicate with any MCP server. This means two things. First, you don't need to wait for big centralized players like Langchain to do all the heavy lifting of tool creation and tool maintenance. Anyone in the open source community can do it and publish it, and it'll instantly work with any MCP client. And second, agent developers don't need to know anything about tools. All they need to do is plug their MCP client to one or multiple MCP servers and let them talk to each other. If you want to dive a little deeper into the technical aspects of the Model Context Protocol, a good place to start is the MCP website itself. You'll find that there is nothing particularly novel from a technical aspect. As we said earlier, it uses a client-server architecture to obtain that crucial decoupling of agents and tools. It uses two main types of transport: standard input-output for same-machine communication, and streamable-HTTP for remote communication. You'll find additional material in the description to dive into each one of these concepts individually. More importantly, MCP uses the remote procedure call, or RPC style, for APIs, instead of the usual REST APIs. RPC is more straightforward and efficient, with only POST requests on customized endpoints, which directly represent functions. REST, on the other hand, is more suitable for CRUD operations, with put, get, and delete on standardized endpoint URLs, which are meant to represent data resources. MCP uses the json-RPC protocol to simplify communication, with highly condensed messages that look like this. They're very simple dictionaries for requests, which contain the name of the method and the given parameters. We also have standard dictionaries for results, and even for errors, with these specific and well-defined error codes, so the model understands exactly what went wrong when a call fails. And that's it. As you can see, the real power of MCP doesn't come from the technical aspects. What MCP really brings to the table is the decentralization of tool creation and maintenance, thanks to the full decoupling of agents and tools with the client-server architecture, and to the standardization of client-server communication, which allows any MCP client to connect to any MCP server. So, is the hype for MCP justified? If you read interesting takes, like this great conversation between the CEO of Langchain and the LangGraph lead, you might be tempted to conclude that MCP is just an over-engineered and flashy way to describe APIs. And you may be right. If you just want to use simple tools on a small scale, there's absolutely no reason to do all this. Ironically, MCP is actually becoming more and more useful, not because it brought anything revolutionary, but because of the hype around it. The open source community is creating thousands of useful MCP servers and having several independent discussions and projects aimed at facilitating the usage of MCP and also tackling and mitigating several difficulties around it. Examples include automatic server creation from Fast API or OpenAPI, deploying MCP servers as Lambda functions on AWS, and making the authorization process more robust and secure. And that's it for this quick introduction to MCP. We hope this has clarified some of the confusion surrounding this topic and helped you position yourself more pragmatically amid all the hype and criticism around MCP. More practical tutorials with code are on the way. If you appreciate the content, make sure you like and subscribe to the channel. See you in the next one. Bye-bye.